Okay, what I have here is a galvanometer, which you may know. It's basically a mechanical uh, detector for electric currents. This is in microamps. I wanted a 35 microamp, positive or negative. Couldn't find one except on Ching Chang Chow, Hong Kong. Order one and maybe take a month to get it. So I went on Amazon. They advertised a 50 microamp galvanometer. I ordered it and they sent me this, if you can see, 500 microamp. It's 0, 500 positive, 500 negative. Called them. They said, well, that was misadvertised. It's a 500 instead of a 50. I said, well, let me order a 50. They said, well, we're out of them. So I've got this, and I'm going to use it because I'm not going to wait till I can find a Ching Chang Chow 50 or 35 microamp or even a microvolt galvanometer. This will work, but I have to make it work so you can see the needle move. What I want to do is everything I've showed you so far with coils was using this multimeter, okay? What I wanted to show you with this little AAA battery, there's the point, if you see it. Find the positive, little positive jobby nabber. You see it there, the positive? I don't know if you can see it. It's right here by my pinky. Positive is to your right, okay? And what I wanted to show with this is that both of them read positive charge of a battery shows a positive reading. Negative charge, reverse that, it shows negative. I'm going to show you that so you see. So I've got positive to the right on the multimeter. Hang on. Get it on there. Yep. It's not showing a reading. Oh, I'm on the wrong setting. Okay. Positive 1.59. Well, it was. Get it on there, right? Positive 1.58. Do you see that? Positive. Now, if I spin the battery around and put the positive of the battery to the negative terminal, I'll get a negative 1.58. Do you see that? Over to the right, okay? Now, this is not going to show a reading because it's going to bury the needle. That's why I'm using this little battery. So I've got the positive to the right again. If you see, there's a little tip. Positive to the right, negative to the left, and watch, the positive over is on your right where the needle goes to the right. And touch, and it buries it. If you see that, I'll do it again. Touch, hang on. These have odd little leads on them. If I can get it to stay on the lead. Touch and it buries the positive. You see that? Touch. Oops. This is very hard to do. These leads on this here are very small. Yeah. It's just hard to get it to stay in place. Positive buried. If I reverse it, get it reversed, and it will, well, if I can get it to stay, bury to the negative, if you see that. Buries to the negative. I don't want to tear this up with a bigger battery. So these both display the same. Positive to red shows a positive and a positive. Positive to negative, or black, shows a negative and a negative. So I want you to see that before we move on. So I've got the meter, which is, this has no electric, no batteries, no nothing. It's just a little magnet with a coil wound around it. Possibly, I think there may be one or two coils. I think it's just one coil. Depending on which way the currents run through, makes the needle go one way or the other. And this, I don't exactly know how it works, but I wanted to show you with the galvanometer that the reading on this and that show the same with a battery. So I don't think it's reversed, which way the electrons are moving or what have you, unless they are both in a reverse orientation, which that's what the whole point of this is to show you what I think magnets are actually doing. And we'll move on. Okay, I've got my right-handed coil hooked up. My left-handed one's over here, out of the way for now. They're mounted on another block of wood for now. And I've got my rotation device, if you can see, red towards us, blue away from us is what the TV screen and the electric current shows us that are magnets rotating according to my demonstrations and experiments. So what I'm going to do is do what we did before, but I want to prove with the meter that's non-electrified, the non-batteried or no electric current with this, it shows the same thing that the digital meter does. So if I put the magnet south away from us, rotating counterclockwise, put it in this coil, this is going to show a positive reading when I push it in. 1, 2, 3, push, positive. And it's going to show negative when I pull it out. 1, 2, 3, pull, negative. I'm going to do it a couple times. And 1, 2, 3, push, positive. 1, 2, 3, pull, negative. And on the outside of the coil, when I push, it'll reverse to a negative. 1, 2, 3, push, negative. And when I pull, 1, 2, 3, pull, positive. It didn't show real well, but 1, 2, 3, push, negative. 1, 2, 3, pull, positive. I'll do it a couple times. 1, 2, 3, push, negative. 1, 2, 3, pull, positive. Okay, so inside it's push positive, pull negative. Outside it's push negative, pull positive. It's reverse with the magnet in the same orientation. All I'm doing here is showing that the meter has nothing to do, the electrical components of this multimeter is going to show the same thing that this non-electrified meter is going to show the same. So when I put the magnet inside, watch the meter will go to plus. If you see over here is the plus and over here is the minus. 1, 2, 3, push to a positive. 1, 2, 3, pull to a negative. Just watch the needle on the meter. I'll do it a couple times. 1, 2, 3, push, positive. 1, 2, 3, pull, negative. I hope you've seen that. One more time. 1, 2, 3, push, positive. 1, 2, 3, pull, negative. And that makes sense. And I'll go on the outside, and it's harder to see because there's barely a movement. 1, 2, 3, push, negative. 1, 2, 3, pull, positive. Watch it again. 1, 2, 3, push, negative. 1, 2, 3, pull, positive. I don't know if you saw that move. So what I've done to enhance that is I've taken a piece of steel tubing like this. It's painted red, but it's magnetic, as you can see. It's steel. And I've taken that tubing and I've centered it inside some PVC like so with some electrical tape, just like this. It's cut off here. That's what this, if you see what I've got here in my hand, these two pieces, PVC tubing and a steel pipe, what I've done is made a core with electrical tape holding the metal inside the plastic, and then the plastic I'm going to slip inside the coil. Okay, so now we have a somewhat of an iron core. Okay, and I've also made another one for the other coil, which I'll show in a minute. The point on this is I can't show the inside readings, but they both showed the same inside, and they did show the same outside. But first, what I'll show you, so there's no discrepancy, I'll plug the multimeter back in. Make sure you can see it. I'm going to put a magnet on the outside and push negative, pull positive. Just watch it on the digital meter. Push negative, pull positive. I hope you saw that. I'll do it one more time. Push negative and pull positive. Did the same thing it did without the steel core, okay? No discrepancy there. So now I'm going to plug this in, the galvanometer, non-energized, non-electric, and I'm going to do the same thing. This way you can really see the needle move. Outside is push negative, if you see it, pull positive. I'll do it a couple times and watch the needle there. Hang on, my magnet's stuck on me. So watch the needle here for positive here, negative there. Push will be negative, negative movement, and pull positive. One more time, push negative, pull positive. So what I want to do set up here is set up the fact that the digital multimeter shows the same thing that the non-energized, non-digital analog galvanometer shows. The motion of the magnet in that orientation, as this shows, does the same exact thing on readings. That was to set that up for us, okay? Now we're going to move on to showing you a little bit more. Okay, now I'm back to the setup with the wheel, and I had a viewer suggest I go down to just one magnet. So I've got one magnet on there, south side out, which will put our field this way towards the coil, rotating like that from that end towards the coil. I can't really get that to where you can see it, but maybe if I place it up here somewhere, I don't know. Maybe you can see it. The red towards us, the blues towards the coil. Well, what I want you to notice is even with just one magnet, if I pass by at a slow rate, it'll still go positive, negative, and positive, negative. And if I go back the other way, it'll be negative, positive, positive, negative, negative, positive, positive, negative, negative, positive. And I want you to see that. Positive, negative, negative, positive. So even with just one magnet, it shows that. And he said it's kind of like an alternating current, and it sort of is, but with no steel core in there, it's not going to have much power. Positive, negative, negative, positive. But a true, just for the sake of what I mentioned when I posted back, is a true alternating current is what they did back in the day, was they had the coil wound in the same direction, but they'd have a south, a north, a south, and a north, is which I have these set up now. It's alternating. Every other one's south, every other one's north. If you watch the meter, it will be more of an alternating current. And if you notice, it's trying to show mostly one or the other. Okay? But if I put the steel core in, it gets a little more explanatory. Positive, positive, negative, positive, negative. But this throws it off whack. But that's how they did it back in the day, was just swap your magnets on the same wound coil, whatever direction it was. Didn't matter. It was just as long as it was going back and forth. Didn't matter which way the coil was wound, as long as all four coils in the generator were wound the same. But this doesn't show a true alternating current, because it's just the magnets are too oddball set up the way they are with each other. But what I wanted to show with this setup was that even without the voltmeter and just using the galvanometer, it does show the same response with this orientation of the magnets this way. Let me turn these back. Everybody south out. And as we know, it all reverses when you go north out. So there's no change there other than it reverses. But this will show a positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. And if I put the steel in, it's a little more advanced, but the positive is not near as intense as the negative for some reason on either with or without the steel core with the galvanometer. Positive, negative, positive, negative, positive, negative. The positive seems to be a little less powerful than the negative. Positive, negative, positive, negative, positive, negative. And this is where it looks like an alternating current if I speed it up just a little bit. It just seems to go back and forth. And I'm telling you, it's not just the recoil of the meter, because if I just go halfway through the coil and stop, it almost stops at zero. It bounces back a wee bit, but not near like this. See how the double pull? It's almost 100 milliamps in both directions. But the positive's always a little less than the negative. And I don't know if that's because the magnet's pulled faster as it goes by is what I'm seeing. But it is an alternating current, even though it's all souths, if you see that. Like I said, if I just stop halfway, the recoil of the needle doesn't jump up to 100. But if I let it go, it's back and forth almost at 100 on both at a certain speed. If I get too fast, it interferes with itself. So I wanted to show you that there's a positive and negative orienting all the magnets the same direction with the magnetic field oriented that way, where it's rotating this way. And there's a reason that does that, and I'm going to show you after a while what I think is causing that. And I can turn this around. The left-handed coil over here does the exact opposite of this. If I must do that, and you think I have to do that to show you that everything I just showed you on the right-handed coil will reverse, and everything I just showed you on the right-handed coil by reversing the magnets reverses, I'll go ahead and do that, but it all just reverses. Everything I showed you right here was south to a right-handed coil, reverses when I put north-south, and all of that reverses with the left-handed coil. But now, when I get to part 4 of this series, I'm going to tell you why, even though this magnet is rotating in this orientation, as it comes into the coil, it's rotating this way. That blue is rotating down in the back, up in the front. Then when it gets so far through, it shows negative, or in the front, it shows positive when it's rotating in that direction. And on the other half of the coil, it shows negative, even though it's rotating in the same direction. I'm going to show you why I think that does that, and why, because the coil is wound this way, why it does it as we see it. Furthermore, I'm also going to show you, let me move these out of the way, and I want to go back to this with the magnet orientated this way. I'm also going to show you why, and this is really more explanatory of what I'm going to say, but the second address to it will be the same. Even though this magnet, according to all the demonstrations I've showed, is rotating in the way that this wheel is showing, that way, counterclockwise. And when I push, if you can see the meter, let me try and get this organized again. If you can see the meter, on the inside, when I push, it's a positive. When I pull, it's a negative. But outside, when I push, it's a negative. And when I pull, it's a positive. I want to show you why I think this is doing this, and why the other orientation of the magnet this way, it does what it does. And I'll get to that in part 4, why I think it does what it does. And we'll come back to that after you guys post some responses on this. Laters.